is a nice circle question. So I'm going to label what I know. I know that I've got a semicircle and I know the radius of the semicircle is root 3. So that length there must be root 3. To be honest, this is my advised starting point in any sort of question with circles. Like put the radius in. You're going to be using it somehow. It's going to be like integral to the solution. This is also root 3. And one other piece of information that we are given is that it's an equilateral triangle, which means that is 60 degrees. That is 60 degrees. And the most important one is that is 60 degrees. Because now I have a right angled triangle, because this is going straight down. It tells me that, what does it tell me about x? Well, essentially, QR is because QR just touches the circle, then it's a tangent, which means that x to O must be at right angles to that. They are necessarily perpendicular lines. So I can write down, for example, that tan 60 is equal to the opposite root 3 over the adjacent xr. And this is where you need to know your trig values, really important. So in fact, tan 60 is root 3. I'm not going to go into any detail on that here, where that comes from, but like I've got videos elsewhere that talk about it, or look it up. You can derive it from an equilateral triangle. In fact, there's memory techniques for it, but basically get it learned, which means that xr is equal to 1. Okay, that's useful. Right, now let's work out what OR is. So I'm still gonna use that root 3, I think. Yeah, why not? So let's go with the sine now. So sine 60 is gonna be, this time it's root 3 over OR. And sine 30 is a half. Sine 60 is root 3 over 2. Again, one to learn. So we can rearrange that or simply look at it and see that OR is going to have to equal 2. And we're nearly there, in fact, because we now see the length of the equilateral triangle is going to be 2 plus root 3, which means that Q to R is going to be 2 plus root 3. And therefore QX, we just need to minus 1 from it. We're going to get 1 plus root 3. And that's our answer, D.